Relay for Life touches us in a lot of different ways, and I would like to introduce today's guest speaker. Today we're honored to have Paul Pagano with us. Paul is a cancer researcher at UCLA. The last name may sound familiar. He was Richard Pagano's brother. And welcome Paul Pagano with a round of applause.
Good morning. As David mentioned, my name is Paul Pagano, and I do cancer research at UCLA. Before we begin, I just want to express my gratitude to the Relay organizers and all of you for inviting me here to speak today. Hopefully I can provide you with a unique perspective with my experiences on cancer. My first encounter with cancer was in middle school. My Aunt Jeannie, who loved me, who picked me up from school when I was sick, and had this level of creativity that was just inspiring and out of this world, was battling with brain cancer. Even when suffering through chemotherapy and radiation, she still continued to be creative. I remember the living room that my cousins and I once played in was filled with a hospital bed and medical equipment. But Aunt Jeannie was at the kitchen table, making beautiful Christmas ornaments out of old burnt-out light bulbs. That's what she did. Her astounding love, her passion, creativity, and perseverance is how I will remember her. My second encounter with cancer happened a few years later. My grandfather came to the United States from Italy in the early 1900s. Armed with a second-grade education and a shoe repair apprenticeship, he grew a thriving business, upon which he successfully raised 7 children and 16 grandchildren, of which I am one. He was diagnosed in 2000 with lymphoma, of which he suffered for about a year. I will remember him for his thick Italian accent, picking olives and oregano in his backyard, the love he had for his wife, and the love he had for his family. 3 years later, I began working for a company that made therapies for cancer patients. By this time, I was fresh out of high school, and I was in college studying biology. I knew that I wanted to be a scientist, but at this point, I wasn't sure what I wanted to research. The company was celebrating the recent FDA approval of a new drug used to treat a side effect of chemotherapy called oral mucositis. It causes very painful sores in the mouth, and it can make simple things like eating and drinking incredibly painful. My grandfather suffered from this. I remember him swishing ice chips in his mouth to dull the pain, as this is the best therapy that the doctors could give him. At the time that he was suffering, less than 5 miles from the hospital that he was being treated in, the company that I was now working for was leading clinical trials for this drug called Kepivance, a drug used to treat and prevent oral mucositis. If I only knew then what I know now. They had stockpiles of it. Could I have reached out to this company and fought and somehow placed him on a clinical trial that would have substantially increased his quality of life? I will never be able to answer this question. It was this experience and others that helped shape my decision to be a cancer researcher. In college, most of the classes that I took discussed cancer and described it as a problem of uncontrolled cell growth. And if you ask most scientists and clinicians, they'll say the same thing. The majority of drugs aimed at destroying cancer is to target this uncontrolled cell growth, with the thought being if you kill the cancer cells, you can save the patient. Another aspect of cancer is metastasis, or the spread of cancer to different parts of the body. Much is less known about the process of metastasis, but we are starting to understand that cancer cells must undergo a series of changes in order to leave the original tumor, enter the bloodstream, and land in a different part of the body. With the exception of blood cells, most other cells in the body typically are not supposed to move. In fact, the body only mobilizes cells in emergencies and for short periods of times, like during a cut or a scrape. While at UCLA, I have decided to study metastasis, and the basis of my scientific research is very simple. While the formation of a tumor is a problem of uncontrolled cell growth, I believe that metastasis is a problem of uncontrolled cell movement. Similar to growth, there are normally many provisions in place to regulate cell motility. I'm trying to understand what signals prevent a normal cell from moving, and how some cancers have bypassed this process. The long-term goal of my research is to somehow develop therapies that will specifically inhibit cancer cells from moving and potentially inhibit metastasis. Perhaps people at risk for cancer could take this drug in a preventative manner. because I and many other people think and know that preventing cancer from moving to different parts of the body would have a substantial impact on beating this disease. I've recently made some very interesting strides in my research that I'd like to share with you. About a year ago, I was recording cancer cell movements under the microscope in order to track their speeds. And what I found was very, very surprising. A small percentage of the cells, less than 1%, moved about 10 times faster than any of the other cells. To put this in perspective, Usain Bolt holds the world record for the 100-meter at 9.58 seconds. To be 10 times faster than that, a person would have to run 10 times the length of this football field in the same amount of time. My thought is that it's the fastest moving cancer cells that are causing all the problems. But I had a problem. As of this point, it was impossible to study these cells because they were incredibly rare and very difficult to come by. So I set out to create a method to isolate these cells from the slow-moving cells in order to study them better. And after about 8 months of failure, I finally had success. The cells I've isolated reliably move faster, even when I test them months after the isolation procedure, which is enough time for the cells to divide over 50 times. This is critical. It's very, very important. What it tells me and what it tells others is that speed is something that's inherent to the fast-moving cancer cells. They're born with it, and they can pass it on to other cancer cells. The success of this isolation procedure has given me the opportunity to study and test my theory that the fast-moving cancer cells are the ones causing all the problems. In our cancer model in the lab, we've injected these cells into mice, and they form significantly more metastases than the slow-moving cells. There's also a method that we use in the lab in order to look at what genes are being expressed during this process. And what I've noticed is a gene encoding for a protein called cadherin has been turned off. This gene, cadherin, is involved in cells adhering to one another. This is something that many non-blood-based cells in the body normally do, as it helps keep the cells in place and prevents them from moving. This was a very exciting result. It helps me and other researchers in the field better understand how uncontrolled cell motility and potentially metastasis work. My next step is to find a way to switch the cadherin gene, find a way to turn it back on, and see how this affects metastasis. It sounds really easy, but this is at least another year's worth of work. Once again, I'd like to thank all of you for inviting me here today and giving the opportunity to tell my story. It's truly an honor. Thank you to all of the donors and to the American Cancer Society for all of your fundraising efforts. I don't think I need to tell this group how underfunded cancer research is, but you all make our work possible. Although I'm not currently funded by the ACS, many of my colleagues at UCLA are. I'm funded by the UC Office of the President, the Veterans Administration, and the U.S. Department of Defense, so I'd like to thank them as well. I'll be set up in the booth with Michelle down at the end, so if anybody's interested in seeing some of the work that I've done, I've brought it on my laptop, and I'd be happy to share it and explain anything to you guys. But I would like to leave you with these suggestions. Ask a lot of questions and make lots of noise. Through questioning, we can challenge each other, we can learn from each other, and we can equip ourselves with the knowledge needed to beat cancer. By making noise, our voices will be heard everywhere: local hospitals, research organizations, and Washington, D.C. While there are people like me across the world who have dedicated their lives to beating cancer, it is your active engagement that makes all of our work possible. On behalf of all of the researchers, thank you all for your continued support.